So hello everybody, my name is Tomas Ambra and I'm going to address the logistics models and their roles in reducing uncertainty in the supply chain. However, I'm going to focus mainly on the transportation part of the supply chain. So in order to explain why we need to have certain models, we need to understand what kind of problems they need to solve. So here you see, for instance, the European Commission's white paper issued in 2011, which states that 30% of road freight, which goes over 300 kilometers, should shift to railways or inland waterways by 2030. And this shift should account for 50% by 2050. So what does it mean? Basically, if we consider this unimodal transportation leg, which contains a lot of trucks, the main idea is to actually decongest the roads and shift to this kind of system where you use the trucks only for the first mile and then use the barges or the trains for the main transportation leg. And the last mile is carried out by the truck. So this kind of chain is called intermodal transportation chain. However, intermodality has been here since 1980s. There are also other concepts such as multimodal transportation, intermodal transportation, co-modal transport, and also combined transportation. So since already, I would say even 30, 40 years, you see that the share of railways and inland waterways has remained more or less stable, more or less the same. On the contrary, the road share has been having an increasing trend. So this kind of intermodal chain is not so effective and it's not utilized to its full capacity in a way that the users perceive it as something slow and inflexible and also something which has a limited service offer. So in a way, we can think about different solutions. So what can be the main solution? The main solution is actually to take this intermodal transportation chain and have it organized in a synchromodal way. So what is synchromodal transportation? It actually accounts for flexibility and transparency, which then facilitates dynamic rerouting and modal switching in near to real time, which means that these kind of flexibility features and transparency features should address these deficiencies, which I pointed out before. Besides that, there is something also called the physical internet, which is the network of networks. This means that the way digital information moves through the digital network in the digital internet, the same way the physical goods should flow through the physical internet by using the network capacity. So when there's a certain underutilization of the network, then you should be able to use that network if it's either the railway infrastructure, inland water infrastructure, or capacity of another service provider. So this physical internet, but also synchromodality, they are parts of this broader vision of ATP Alice. They are trying to also devise different pillars to achieve zero emissions by 2050. And the physical internet is a sub part of it, which should be achieved by 2030. And also the main idea is to shift from this underutilized system when you have underutilized capacities, the different hindering factors in between modes, and to shift to this green situation where you have interconnection and interoperability among the nodes and so on. So what is then the role of simulations? So basically, if we want to assess different phenomena and study how these things can work, we need to rely on simulation models. So what are simulation models? I can compare it to the COVID-19 situation that everybody is very well aware of now. So on the left side, you see that this is a situation for the free-for-all movement. And on the right side, you see that this is a moderate distancing. So you have some certain social distancing. And based on these kind of simulation outputs, you can see that there's a certain curve, which should be also flattened. So this is actually how we flatten the curve, by having social distancing. And before, nobody really knew about the curve, and that kind of curve needs to be flattened. So basically, based on simulation models, we have this extra understanding of the situation. So basically, you can assess situations which never happened before. And this figure also shows similar things. So basically, you can rely on data-centric approaches, where you have different solutions which are based on the data before. But the question is, how do we adapt, or how do we make the system more resilient to phenomena which never occurred? So basically, you don't really have any historical data here. So basically, you need to really rely on the fidelity of physics, business rules, constraints, which you actually mimic in the simulation models. And the simulation models then generate data that you can actually use for different assessments. One of our main simulation models at MOBI is the SYMBIT model, which means it has a main skeleton which actually depicts all the ports and terminals. And also the last mile is more or less included at an ad hoc fashion, which means that we geocode the locations later on when needed based on the case. So I'm going to show you two cases. So basically here you see certain agents. So these are actually agents which flow between different nodes. So what is an agent? An agent can be, for instance, the barge, which you can see here. They follow the inland waterway infrastructure. Then we have also the vans or trucks or different small cars that can follow the road infrastructure. So SYMBIT is devised now around two cases. So the first case shows you the interregional flows of SYMBIT. So here we tested it on flows from France to Belgium, and we exposed this intermodal system to disruption. And we use these kind of disruption profiles you can see over here. And the main result was that intermodality performs actually better than synchromodal transportation when it comes to disruptions that have shorter times of severity, or I would say shorter times of delays. So in a way that the dynamic rerouting is not always better because it sometimes results in unnecessary deviations. So the green locations, so the green points here that represent orders. So each point is one order. So here you see that the orders actually generate extra distances at higher cost. However, if you deploy the model for more severe disruptions, which can be like, let's say 1 or 3 days, then you see that the dynamic rerouting and model switching can actually contribute to lower cost and lower delivery times or the lead times, as you can see based on the green dots of the deliveries. We also had another deployment which was for urban logistics. As you can see over here, here we assess the insertions of extra service points into existing network of a service-driven company. And here the main conclusion was that the more orders you insert into a network, you can result, or this can result in a total decrease of the vehicle kilometers of the entire system. In a way, so this is my show-off slide. SYMBIT also won the first prize in 2018 at CRA Visions. So we received a prize from the European Commissioner for Transport and also a financial prize sponsored by ECP Alice. Of course, I have only a limited time, so I can't really dig deeper into this. So if you're interested in the pseudocodes, if you want to know more about the cases and the algorithms, I would like to refer you to the following journal publications where you can find all of these. And currently we are extending the SYMBIT features, which is for now a digital simulation model. We are trying to connect it to real-time data feeds, which means that we are extending the capabilities of SYMBIT by making it into a digital twin. And for this, we have engaged in a project called Dispatch. So if you want to know more about the project, you can visit our website. Also, these are the companies and other entities involved as well. So this is it